So today we're going to talk about drawing ionic bonds, and to do that we need to know how to do Lewis dot diagrams, we need to know about valence electrons, and we need to know about ions. So first order of business is an ionic bond is a bond between a positive ion and a negative ion. Or you could think about that as being a bond between a cation and an anion. Remember that cations are positive because they've lost electrons. Those are typically the metals. And an anion is a negative ion that has gained electrons, and those are typically the nonmetals. And we can think about this as being a transfer of electrons. So that metal that loses an electron is going to give the electron to a nonmetal who gains it. And so we do that to have the same configuration as a noble gas. So the noble gases are this group over here on the right, group 18. Those are the noble gases. So they have a very stable configuration where their outer shell is completely full. They have all the valence electrons that they need. So all of the atoms on the periodic table are not stable until they have that full outer shell like the noble gases. So that transfer of electrons is going to happen so that they will be like the noble gases. And the overall compound itself is going to have a neutral charge. So the positive will cancel out the negative. That's the goal, is to have an overall charge of 0. So for our first compound, we're going to draw a bond between, we're going to start with potassium and chlorine. So that will be our first compound that we're going to draw. So we know that the potassium it's in group 1, so it has one valence electron. So when I draw the electrons, I'm just going to draw one electron, because it's in group 1. This is group 1. Chlorine is over here in group 17, so it's going to have 7 electrons. Let me change the color here. It will have 7 valence electrons, so those go around chlorine. 7 electrons. So you can see how this electron is going to fill the empty space on chlorine. So potassium, right here, number 19, has a very close atomic number to argon, which is 18. So it's going to lose that electron, and it's going to have now the electron configuration of argon. So remember, when it's neutral, it has 19 electrons because that's how many protons it has. 19 is the atomic number. So the number of protons is 19. So when it's neutral, it also has 19 electrons. When it loses that electron to chlorine, it goes back to 18 electrons, which is a noble gas. If we look at chlorine, right there, we can see that its atomic number is 17, so 17 protons. When it gains that electron from potassium, it will now also have the same configuration as argon with 18 electrons. So both of these elements will be happy as ions because they will look like argon. And so all we have to do now is write the formula, and we're going to put the two symbols together. We don't need any subscripts because I only used one atom of potassium and one atom of chlorine to make this happen. So the formula is just KCl, and you put them together like that. It's important to know that in the formula, you have to write the metal first. So the cation always goes first, which is the positive ion, and then you write the anion, or the nonmetal, the negative ion. So that always goes second. And we will discuss how to name this a little bit later. But that's how you draw it. So when potassium loses that electron, it becomes positive 1. And then when chlorine gains that electron, it becomes a negative 1. So that's the charge. So let's move on to our next example. We have Be, which is beryllium, and O, which is oxygen. So on beryllium, I can see that it is here in group 2. So it gets 2 electrons. So I'm going to draw my electrons here. Okay, oxygen is over here in group 16. So it gets 6 electrons. So I'm going to draw my 6 electrons on oxygen. Okay, so if you can see here, I've got 2 empty spaces on oxygen. I've got 2 electrons that don't have a pair. So you can see these ones are paired up. They have a friend. Whereas these electrons, they do not have a friend. They have empty space. Where over here on beryllium, I've got these 2 electrons. And so I know that beryllium's going to lose these electrons because it only has 2. So the options are it can either lose those 2 electrons to go back and be like helium, or it can gain 6 electrons to be like neon. Now 2 is less than 6, and we want to always use the least amount of energy as possible. So that means that losing 2 electrons is going to be way easier than gaining 6 electrons. And remember, these are only the valence electrons. We're not talking about the electrons in that first energy level. We're leaving those alone. We only care about the electrons in the outer energy level, the valence electrons. So let's go ahead and show this transfer here. So this electron can go and fill this space, and then this electron can go and fill that space. And that way, my beryllium is going to form a +2 charge when it loses those 2 electrons, and my oxygen is going to form a -2 charge when it gains those electrons. So if I look at the charges, my +2 and my -2, okay, I can see when I put those together that gives me 0. I get a neutral charge. So I'm done here. All I have to do now is write the formula. So again, the metal goes first, and then the nonmetal. And that's it. Everybody's happy. On my next example, I've got aluminum, and I have P, which is phosphorus. So again, if I look at the what group they're in, aluminum is in group 13, so it's going to have 3 valence electrons on the Lewis dot diagram, and phosphorus is in group 15 under nitrogen, so it's going to have 5 valence electrons. So draw the dots there. So when you have your ionic bonding, you're just going to draw your arrows so that the electrons are filling the empty space, so that all of your electrons are paired up. Okay, so now I've used all of my electrons from aluminum, and I've filled all of the spaces over on phosphorus. So I don't have any extras, and I don't have any spaces to fill. So aluminum is going to form a +3 charge when it loses those 3 electrons, and phosphorus is going to form a -3 charge when it gains those 3 electrons. And so when I write my formula, I just put the symbols together, ALP. Okay, now let's do some examples where we have to use more than one ion from an element. Okay, so here I have calcium and I have fluorine. So if I look, calcium is in group 2, fluorine is in group 17. So I'm going to draw my dots, draw my valence electrons on my atoms here. Okay, now, so when I go to draw this, I have this happening here, but now I don't have any more spaces on fluorine. Fluorine is full, but I still have an electron that I have to get rid of from calcium, because remember, we want an overall charge of 0. So that means what I have to do in this case is I need another fluorine atom. So I need another fluorine, so I'm going to draw that here. And there you go. So now I can show this electron transferring there. And now I've used all of my electrons from calcium. It's going to be +2. This fluorine's going to be a -1, and this fluorine's going to be a -1. So when I look at this charge, and this charge, and put everything together, my +2, and I've got 2 that are -1, put them together and I get neutral. I get 0. They cancel each other out. It balances. So I'm going to write the formula. Remember, we write the metal first. So it goes calcium, and I only have one of those, and I have 2 fluorine ions here. So I have to write F for fluorine, and then I put a little 2, and that's called a subscript. And it tells me how many fluorine atoms I need to make this happen. they're ions now. So how many fluorine ions I need to make this happen? Okay, so CaF with a little 2. All right, next example is sodium and sulfur. So I have sodium in group 1, 1 valence, sulfur in group 16, so that's 6 valence. So go ahead and put those on there. Sulfur should have the same electron configuration as oxygen. We did that earlier, and sodium has the same configuration as potassium. Okay, so I can see how this would transfer, but sulfur is not satisfied because it doesn't have an 8th electron. So now it has 7. It has 1, 2, 3, 4, 5, 6, and 7 now, but it needs 8. So what I need to do is I need another sodium so I can have another electron, and that will fill that empty space. And so now when I write the formula, I have to write the metal first. So I wrote sodium first. And how many sodiums did I use? I used 1, 2. Okay, so I get a subscript 2 there. And I only used 1 sulfur, so I just write an S. So Na2S is the formula. And that's it for that one. This one here, this one can be a little more complex. So I have calcium, which is in group 2, and I've got nitrogen in group 5. So I've got 2 on calcium, and I have 5 on nitrogen. Okay, so again, starting to draw my arrows here. Okay, there we go. There we go. So I got rid of all my electrons from calcium, but I still have a spot over here that is not satisfied. So I've got to give us another calcium. Let's see here. So calcium. Again, 2 dots. I'm going to draw it on this side just so it's a little bit easier with the arrows. Okay, so this one goes here. Now that nitrogen is full, but calcium, I still have this electron to get rid of. So what we need to do is we need another nitrogen atom. So it seems like this is getting a bit messy, but that's what we have to do until we have used all of the electrons and filled all of the spaces. So here's my other nitrogen atom. So I'm going to make it an ion by adding electrons to it. I got to get rid of this electron here. Okay, so now again I have a situation. I have all of my electrons on this calcium taken care of. This nitrogen's happy, this calcium's happy, but this nitrogen, you can see I still have 2 spaces. So I have to draw another calcium. So here we go. Calcium here, again, 2 electrons, and I'm going to transfer them over. And now finally, I have all the electrons used and all of the spaces filled. So this calcium forms a +2. I'm just checking my charges. This one's a +2 and this one's a +2. And then both of these nitrogens are a -3. So if I count up all my charges for my positives, I've got 2 + 2 + 2 gives me 6. So overall I have +6. Okay, and then I count up my negatives, and I've got a -3 and a -3. Those give me a -6. Okay, so overall, that gives me a charge of 0. Okay, so then when we're writing the formula for that, our formula is just going to be calcium goes first, so Ca, and how many calciums did I use? So I count them up. I used 1, 2, 3. So my subscript on that is going to be 3, and then nitrogen's my nonmetal. So N, and how many nitrogens did I use? I used 1, 2. So my subscript is 2. So Ca3N2, that's going to be my formula for that one. Okay, a few more examples here. Aluminum and sulfur. So aluminum, 13, so 3 valence electrons. Sulfur in group 16, so 6 valence electrons. So here we go. 1, 2, 3, and 6. Okay, so again, we're just going to start transferring. Okay, same problem I had last time, except the opposite. Now instead of having too many spaces left, I've got too many electrons left. So this electron has nowhere to go. So what do I need to do? I need to draw another sulfur atom. So sulfur, I kind of have to draw it small here. So I've got 1, 2, 3, 4, 5, 6. So now I have another space for this electron to go. So it can go there, next to that electron. But as you can see, I still have a space that's not filled with that electron there, so I need another aluminum. So aluminum with 3 valence electrons, again, because it's in group 13. So I'm going to put this one here. But now I've got these two. Those two are not happy. They don't have anywhere to go. So as you guessed it, I need another sulfur. Sulfur here. 1, 2, 3, 4, 5, 6, because it's in group 16. One more time. This one can go there and there. And now we're finally satisfied on all ends. So, aluminum. It loses 3 electrons. What does that make the charge? It makes it positive 3. So both of these are plus 3. Sulfur, it's gaining 2 electrons. What does that make the charge? Minus 2. All of those are a minus 2. So again, just to reiterate, sulfur, here, it's going to gain 2 electrons to look like argon. And then we have aluminum here, where it's going to lose those 3 electrons so that it looks like neon. It's going to be easier to lose 3 electrons than it would be to gain 5 electrons. So losing 3 is the way to go. So again, we're going to look at the charges here. We're going to tally them up. I've got positive 3, positive 3. That gives me plus 6 overall. Okay, and then negative, I have here negative 2, negative 2, negative 2. So 2, 4, 6. So I've got negative 6. Add those together. It gives me an overall charge of 0. They cancel out, which is wonderful. So writing the formula. Remember, the metal goes first. So I have aluminum. How many aluminums do I have? I've got 1 aluminum and 2 aluminums. So aluminum 2. And then how many sulfurs do I have? 1, 2, 3 sulfurs, so S3. There you go. Aluminum 2, S3. Okay, one more example, and then you'll be ready to go. You'll have seen just about everything. So I've got lithium and phosphorus. So lithium, group 1, 1 valence electron. Phosphorus, group 15, 5 valence electrons. So 1 and 5. All right, so we start our transfer. There we go. And I'm already out of electrons, so I need another lithium because I still have some spaces that need to be filled on phosphorus. There you go. And I've got this last space over here, so I need 1 more lithium. Okay, there we go. So looking at the charges, lithium loses an electron, so it forms a positive 1 charge. And phosphorus is going to gain 3 electrons, so it's forming a negative 3 charge. And so if I count that all up, I've got 3 positives and 3 negatives. They cancel out and give me 0, which is great. That's what an ionic bond is all about. And so writing the formula, I always have to write the metal first, so lithium. And how many lithium ions do I have? I've got 1, 2, 3. So lithium 3. And then I only have the 1 phosphorus, so just the P there. Okay, and that's going to be it. So you guys are ready now to get going on your own and drawing some examples.